Morning. In this lecture, we will discuss about what are basic antenna parameters. In the basic antenna parameters, we will discuss about radiation pattern and about radiation intensity. At the end of session, we are able to know the antenna parameters, what are the antenna parameters, understanding the radiation pattern of antennas, and know the definition of radiation intensity. Antenna parameters. In the previous classes, we have seen what is an antenna, definition of antenna, different types of antenna, applications of antenna. Now we will go to the antenna parameters. Antenna parameters are classified into generally three types: circuit quantities, physical quantities, space quantities. In the circuit quantities, we study about antenna impedance, radiation resistance, antenna temperature, etc. And in the physical quantities, we will discuss about size, weight. In the space quantities, we will discuss about radiation pattern, nothing but field pattern, power pattern, polarization, beam area, directivity, gain, effective aperture, radar cross section. So these are the basic antenna parameters that we will discuss in the coming topics. Okay, these are the antenna parameters. Majorly, the antenna parameters are classified into three types: circuit quantities, physical quantities, and space quantities. In this lecture, we will discuss about radiation pattern. Now, what is a radiation pattern? We all know that antenna radiate electromagnetic waves into the free space in all direction from the antenna. In some direction, it may radiate more, and in some direction, it radiate less. Okay, it radiate in all directions into the free space. Now we will see what is radiation pattern. Once the electromagnetic energy leaves the antenna, the radiation pattern tells us how the energy propagates away from the antenna. Mathematical function or graphical representation of radiation properties of an antenna as a function of space coordinates. In most cases, the radiation pattern is determined in the far field region and is represented as a function of the directional coordinates, nothing but distances. Radiation pattern includes power flux density, radiation intensity, field strength, directivity, phase of polarization. These are the quantities we'll discuss in the radiation properties. Now, what is a radiation pattern? The energy radiated by an antenna is represented by the radiation pattern. I have already said that the antenna will radiate EM energy in all directions. In some directions, it radiate more. In some direction, it is radiate less. Okay, the energy radiated by antenna is represented by the radiation pattern of the antenna. Radiation pattern are diagrammatical representation of the distribution of radiated energy into the space as a function of direction. The radiation pattern can be field pattern or power pattern. The field pattern are plotted as a function of electric and magnetic fields. They are plotted on logarithmic scale. The power patterns are plotted as a function of square of the magnitude of electric and magnetic fields. They are plotted on logarithmic or commonly on dB scale. The field pattern are plotted on logarithmic scale, and whereas power pattern are plotted on dB scale. That is the difference. For an antenna, we have field pattern. Typical represents a plot of magnitude of the electric or magnetic fields as a function of angular space. Power pattern typically represents a plot of square of the magnitude of the electric and magnetic fields as a function of angular space. Power pattern represents the magnitude of the electric or magnetic field in decibels as a function of angular space. Radiation pattern examples. The graphical representation of radiation from an antenna is nothing but the radiation pattern. Okay, so graphical representation means the radiation pattern we have to represent in the space. That is three-dimensional quantities. Okay, So we have to represent the radiation pattern in three-dimensional representation, nothing but spherical coordinates. You know the spherical coordinates parameters are theta and phi. So this is the radiation pattern of an antenna representation using the spherical coordinates. Okay, it consists of elevation plane, azimuthal plane. Okay, radiation pattern is represented in three terms: ER, E theta, E phi. But we will not consider the ER radiation pattern. We will consider only E theta and E phi. So this is the radiation pattern representation using three-dimensional spherical coordinate system. So these are the different type of lobes in the radiation pattern. The red color represents the main lobe in which the major part of radiation is concentrated. Just just behind the main lobe, we will find back lobe. The remaining small lobes on the side of main lobe are called as side lobes or minor lobes. The main lobe is also called as main lobe or major lobe, and just behind the main lobe is known as back lobe. The other small lobes are called as minor lobes or side lobes. The gap between the lobes is called as nulls. That means there is no radiation in that part, so they are called as nulls. We have already discussed that the radiation pattern can be represented in terms of field pattern and power pattern. So these are the representation in terms of field pattern and representation in terms of power pattern. We know that the relationship between power pattern and field pattern is Pn of theta is equal to En square of theta. In this representation, field pattern and power pattern, we have seen two parameters, HPBW and FNBW. FNBW means beam width between the full nulls. BW means beam width between the half power beam, or it is also called as half power beam width. It is called as full null beam width. The beam width is calculated at 0.707 En for field pattern. The HPBW calculated for 0.5 Pn. So this is the difference between field pattern and power pattern. So this is representation of power pattern in decibel scale. So the middle one, bigger one represents the main lobe. Remaining small elevations represents the side lobes and major lobe, minor lobes. And the last lobe represents the back lobe. This is the decibel scale representation of power pattern. Principal patterns. There are two type of principal patterns or principal planes, E plane and H plane. E plane, the plane contains the electric field vector and the direction of maximum direction. The plane contains the magnetic field vector in the direction of maximum radiation. So there are two type of principal patterns, E plane pattern and H plane pattern. Those are shown in our diagram. Radiation pattern can be classified as either isotropic, directional, and omnidirectional. We know what is an isotropic antenna. Isotropic antenna is a hypothetical antenna which radiates equally in all directions. Isotropic antenna having equal radiations in all directions. Directional antenna having a property of transmitting or receiving electromagnetic energy more effectively in a particular direction than other directions. Omnidirectional, having essential non-directional pattern in a given plane and a bidirectional pattern in any orthogonal plane. So these are the three different type of radiation patterns. So this is the two-dimensional representation of radiation pattern from an antenna element. Types of radiation pattern. The common types of radiation pattern are omnidirectional radiation pattern. The pattern usually has a donut shape in three-dimensional view. However, in two-dimensional view, it forms as a figure of eight pattern. Pencil beam pattern. The beam has a sharp directional pencil beam pattern. Fan beam pattern. The beam has a fan-shaped pattern. Shaped beam pattern. The beam which is non-uniform and patterns is known as shaped beam pattern. Shaped beam pattern means the pattern is not an uniform pattern. So far we have discussed about radiation intensity. Now we will discuss about radiation pattern. Now we will discuss about radiation intensity. The power radiated from an antenna per unit solid angle is called as radiation intensity. The power radiated per an antenna per unit solid angle is known as radiation intensity. The units for radiation intensity is watts per steradian or square degree. The expression for the radiation intensity is given below. The normalized power pattern can also be expressed in terms of parameter as the ratio of radiation intensity as a function of angle to its maximum value. So the below the radiation pattern intensity expression is mathematical representation is given. Beam efficiency. The total beam area or beam solid angle consists of main beam area plus minor lobe area. The total beam area consists of, we know that the total beam area consists of main beam area as well as minor lobe area. So thus the main beam area is equal to omega A is equal to omega small m plus omega capital M. What is omega small m? Minor lobe area. What is omega capital M? Main beam area. The ratio of main beam area to the ratio of main beam area to to the minor beam area is called as efficiency. Beam efficiency is equal to omega capital M by omega A. The ratio of main beam area to the total beam area is called as beam efficiency. So these are the parameters we have studied. Thank you.